Breaking overnight, a major Ukrainian attack on Moscow. Russia says its air defense destroyed more than 140 Ukrainian drones launched.
Seems as though the Ukrainians have upped their long-range drone capabilities.
Ukraine's use of drones has proved a vital tool in stopping the Russians.
You're listening to War Tech Talks, Eastern Circle's podcast on military technology, innovation, its battlefield application in Ukraine, and geopolitical impact. I'm Anastasiya Shapochkina, president of Eastern Circle's think tank in Paris.
And I am Elitsa Gadeva, journalist and editor of this podcast. In this episode, we will lay the foundations and discover the history of UAV drones.
UAVs date back all the way to July 1849, the siege of Venice. Venetians revolted against Austrian rule, and the Austrians decided to use the invention of their engineer, Lieutenant Franz von Ucatius. He invented the first autonomous air bomb, made of balloons filled with shrapnel. Launched from the Austrian side, the balloons were moved by wind to fly toward and explode over Venice.
So, did it work?
Not really. The strikes had little tactical effect, but managed to cause psychological damage. At the same time, they had inherent weakness. As they were moved by wind, many were blown back to Austria, where they exploded. However, the invention marked the start of a new era of UAV development and set the stage for the drone technology we know today.
The UAV technology was taken to a new level during the First World War. This is when American engineer Charles Kettering invented an aerial torpedo called the Kettering bug. The torpedo was considered the world's first cruise missile. He was working in a team of inventors who made the first cars and plane engines for the Dayton-Wright Company supplying the US Army during World War I. They called it the Kettering bug because it looked like a flying insect or some sort of a primitive airplane.
Why primitive?
The materials that were used would be quite questionable today. The flying bombs were built of papier-mâché and textile, featured a gyroscope and barometer, and were intended to fly to their target before plunging to Earth and exploding, in the same way that modern kamikaze drones do today.
Testing these first drones was ridden with problems. Most of the tests resulted in crashes because of the limited aerodynamics knowledge during World War I. Engineers were also unable to perfect their product. They were facing time pressure because of the ongoing war. The crash rate was 6-1, which drove up the costs and made scaling up impossible. At the end, none of the torpedoes were tested in real combat, and the end of the war limited the production of the flying bombs. A few months after World War I ended, Dayton-Wright Company dissolved because of low demand, and its team went back to making cars and civil planes.
Between the First and Second World Wars, military drone development and testing continued in Britain under Churchill, where the Royal Air Force led its own program of radio-controlled gyro-guided missiles. The British aircraft company, de Havilland, produced radio-controlled aircraft used for training targets. We can call this the first modern drone. The term drone was actually inspired by the name of one of these models, the DH-82B Queen Bee, because male bees or drones are controlled by the queen just like the UAV is remotely controlled. The main body of the Queen Bee was made of wood to save costs. It first flew in 1935. It had an engine power of a Mini Cooper and a wingspan of a Golden Eagle. It could speed up to 170 kilometers per hour with a maximum distance of 480 kilometers. In the next decade, the Royal Navy and the Royal Air Force ordered 412 units.
Already from those three examples, we can observe the evolution of drone technology. From papier-mâché to wood, growing production scale and range, and the development of more complicated parts. During the Second World War, drones evolved from concepts and failed ideas to practical tools of war. Radioplane OQ-2 was used for target practice by the US Army during World War II, and its successor, radioplane OQ-3, was mass-scaled to nearly 15,000 units produced during the war. Inspired by the British Queen Bee, the model became the first mass-produced UAV in America. The simplicity of its design, a two-stroke, two-cylinder engine, enabled low-cost production. Although much smaller than Queen Bee, an OQ-2 was still too big and heavy compared to modern first-person view drones.
Another Second World War development that's worth mentioning is the remotely controlled BQ-7 aircraft produced by Boeing and the United States Army Air Force. It was a modified B-17 Flying Fortress bomber filled with explosives designed to strike German targets. It wasn't that autonomous, however. The concept involved pilots guiding the drone close to the target before bailing out, allowing the BQ-7 to continue flying on its own. This drone project was essentially a recycling project meant to convert worn-out B-17 and B-24 bombers by stripping them down, loading them with explosives, and controlling them remotely from a follower aircraft. The American Air Force called it Operation Aphrodite. But let's now dive in some of the first World War II missions.
Well, they weren't as straightforward as pilots would have hoped for. The first missions, in August 1944, were marked by technical difficulties, crashes, and missed targets. For example, the BQ-7 intended for the German V-1 bunker, located in northern France, didn't even manage to reach the destination. After reaching the designated altitude of a bit more than 600 meters, the plane experienced control issues, eventually spiraling out of control. The pilot was unable to bail out in time, and the plane crashed in the English village of Orford. 2 other BQ-7s were assigned to destroy a V-2 German fortress. One was shut down by enemy anti-aircraft fire before reaching the target. The other encountered visibility issues due to cloudy weather, undermining radio controller guidance, and eventually flying over the fortress it was meant to destroy. So we could see how these first drone attacks disrupted some German operations, but did not achieve the intended strategic impact. You see how to understand drone production, we need to look at the full picture. In the 19th century, engineers tested different materials and construction. The 20th century was a period of testing, failing, and crushing. But the partial success of some missions unveiled the potential of the drone technology, which has now changed the face of war.
And now, off to the next stage of drone development, a crucial one, the Cold War period and the impact of drone testing during the Vietnam War. The American Air Force used the Ryan Model 147 Lightning Bug drone for reconnaissance, surveillance, electronic jamming, and psychological warfare. This was achieved through a powerful engine, a lighter airframe, and a significantly advanced camera system.
And how did the Air Force pilots see the use of drones?
Well, with a lot of suspicion actually. The Air Force resisted the development of UAVs. Some pilots didn't trust the technology, whereas others feared they would be replaced by the drones. These concerns echo the ones we can hear from the Air Force members in Europe today. The Soviet Empire is the next actor that gave a notable push to drone development. In the 70s, the Soviets invested in aerial drones to catch up with and outrun America, as Comrade Khrushchev used to say. They developed a jet engine Tupolev 141 drone used for surveillance missions. With a 1,000-kilometer range, it was programmed to fly over a designated area, take images, and return to the control center. It was enhanced with a camera, an infrared imager, and a radar.
What that means is that the Soviets caught up and overtook Western UAV equivalents while learning from the failures of the first movers, the British and the Americans. There is an actor, a region rather, that we're missing. A place that pushed drone development and whose modern warfare nowadays is defined by UAVs.
No doubt you're talking about the Middle East here.
Exactly, and most notably Israel and its drone production capabilities. Israel Aerospace Industries developed its first reconnaissance drone, the Daryna-Maryna, after the Yom Kippur War in 1973, and a surveillance drone, the Scout, used in 1982 Lebanon War to provide real-time intelligence. This experience turned Israel into a world leader in the tactical drone industry.
And did Israel produce all of this alone?
The US Army collaborated with Israel to supply drones to the US Navy and ground forces. As we can see, since the beginning, the US has been behind Israel. Israel's entrance into the drone market marks a crucial step in the development of UAVs, highlighting the East versus West division in the drones arms race.
We shouldn't forget our other Middle Eastern characters. The Iran-Iraq War laid the foundation for Iran's drone tech development with the Mohajer-1 drone produced in 1985 and the reconnaissance Ababil-1 drone. Despite their basic design, these drones established the groundwork for Iran's growing UAV program.
Throughout the last century, drone development was powered by war. This was actually holding technology back, as no matter how long, wars end, interrupting the drone technology progress. This changed in 2005 with Hurricane Katrina, when the US government used UAVs equipped with thermal cameras for search and rescue missions. This opened a brand new market of civilian applications for the old drone technology. Drones broke free from the fatal dependence on wars, discovering fresh investment and scaling opportunities. Regulations sprung up to integrate UAVs into civil airspace, making drones sky regulars from 2006. By the first decade of the new century, companies like Parrot, Del Air, DJI, and 3DR were repurposing former military UAV technology for civilian use, recognizing the vast potential of the market. Aerial photography, agriculture, infrastructure inspection ramped up drone production to a level unimaginable by any war of the past. Except the war of the future, which the world of drones was about to enter.